episode of Mr. Showley's Snapshot Science. Now in today's video we're going to be looking at the kidneys. Now hopefully by the end of this video you're able to, one, recall the structure of the kidneys. We then want to go on to outline how the kidneys produce urine. And finally we want to explain filtration and reabsorption in the kidneys. Okay, so let's shoot off for number one. Let's get right into it. Now, if we're talking about the kidneys, we really need to start by looking at a process known as homeostasis. Homeostasis involves maintaining a constant environment in the body. Okay, the kidneys play a very crucial role in homeostasis. Okay, and if we're not talking about homeostasis and the kidneys, we're really talking about, osmoregulation. Okay, controlling the amount of dissolved substances in the blood and in the tissue fluid. Okay, this is really important. Now, the main role of the kidneys, the primary role of the kidneys is to clean the blood and produce urine. Okay, the kidneys remove any waste from our blood, okay, and they send this waste in the form of urine to be excreted, all right, so they send it to the bladder. Okay, and we're really going to look at today what's going on with these mechanisms. Now, before we actually look at the role of the kidneys, let's look at the structure of the kidneys. Okay, now, the kidneys has, first of all, a renal artery. This renal artery is bringing blood, all of your blood from the body, all of the blood to be filtered, okay, it's bringing it to the kidneys, okay? The renal vein is taking blood, the blood that has now been filtered, away from the kidneys, okay? Then we have the cortex. Cortex essentially means shell, the outer layer, okay? Now the cortex is full of nephrons, okay? And these nephrons are really involved in filtering, okay, the contents of the blood, okay? We then have the medulla. The medulla is essentially the middle layer of the kidneys, okay? And the medulla is involved in filtering the waste, okay? And it also contains the loop of Henle, which we're going to look at, okay? And the loop of Henle is involved in allowing water to pass in and out of the kidneys, okay? We then have, over here, okay, we have the pelvis. This pelvis is the area where the collecting ducts come together and collect to the ureter, okay? Now the ureter, which you can see down here, essentially escorts the urine away from the kidneys to the bladder to be held before it is passed out the body, before it is excreted out the body, okay? So here are some key definitions of the four parts of the kidneys. Pause the video and make some notes on the key parts of the kidneys. Okay, now the kidneys are made up of thousands of tubules. They seem quite solid, but they're made up of thousands of these tubules or nephrons. Okay, each tubule begins in the cortex, so the outer layer. Okay, and it loops right down to the middle, to the medulla. Okay, from the medulla, okay, it then goes back into the cortex. Okay, before it loops right back down to the medulla, okay, and down into the pelvis. Alright, now this pelvis, in the pelvis, the tubules join with the ureter. Remember we said the ureter passes the urine from the kidneys right down to the bladder, okay? Now, just to make it clear, okay, this is what we looked at before. We had the renal arteries, okay, taking blood to the kidneys, and we had the renal veins taking the filtered blood away from the kidneys. Okay, so let's look at the working kidneys. The kidneys takes on all of the blood throughout your body. Okay, the kidneys go through so much work every single day. Okay, they filter about 180 litres of water, okay, out of your blood during a day. However, 99% of the water passes back into your blood. Alright, on average, we produce between 1.5 to 2 litres of urine per day. Okay, that's as long as you're not dehydrated, etc. Okay, now the urine is stored in the bladder where it is held until you need to get rid of it. Okay, now an overview. As we said, blood, which contains water, urea, salts, and glucose, passes into the kidneys. Okay, this is just an overview to start with. The blood is filtered, okay, and this filtrate is then reabsorbed. Some things are reabsorbed, some things aren't, which we will look at in a minute, okay? And anything that is waste goes down to be passed out the ureter to the bladder, all right, in the form of urine. Anything that the body still needs passes out of the renal vein, okay, back to the rest of the body. Now, urine formation. How is urine formed? Okay, we start with, as the blood enters the kidneys, okay, via the renal arteries, okay, we have the urea, water, salts, and glucose. They are filtered in the nephrons, okay, and I'm actually going to show you a diagram of this in a minute, okay. Now, all glucose is reabsorbed back into the blood to go to the rest of the body, and any water or salts that the body needs is also reabsorbed, okay. Excess water, excess salts, okay, and all of the urea is passed out in the form of urine. That's what urine is made of, okay, your water, your salts, and your urea, okay. Now, okay, so we have blood entering the kidneys, okay, via the renal artery, okay. Now this blood enters a ball of capillaries here, as you guys can see. And this ball of capillaries is known as the glomerulus. Now these capillaries pass and they sit in this filter here. This is a filter. This filter, is known as Bowman's capsules or the renal capsule. Okay? Now, small molecules of, as we said before, glucose, salts, urea and water all pass into, alright, the renal capsule. Alright? Larger molecules such as proteins do not, because they're too large to diffuse across. Okay? Now, the filtered blood moves right down the nephron. Okay? And in the proximal tubules, okay, the cells there, they reabsorb all of the good stuff. So all of the glucose, the water that is needed from the body, the salts that are needed for the body. Okay? However, any excess water, any excess salts, or all of the urea is not reabsorbed back into the blood. Okay, we want to get rid of that in the form of urine. Okay, so as the urine moves on, okay, we get to something called the Loop of Henle. Now, as we said, the kidneys are involved in controlling water content. So if more water is needed, it's at the Loop of Henle where that is passed back into the blood, okay, and collected. Alright, and it adjusts the water content of the body. Alright? Now, what we essentially have is the rest, so the waste, okay, passing out of the ureter, okay, to be passed to the bladder where it is collected. So just an overview, brief overview, guys. You can see, okay, the blood comes in, okay, anything that is needed, alright, is reabsorbed, so it's filtered, then we have reabsorption, okay, and we have the passing out of the waste. Okay, so guys, this is just a brief overview of urine production. Okay, pause the video and make some notes on it using this diagram, the previous diagram too. Now, the process can be summarized as follows: filtration, selective reabsorption, and excretion of waste, getting rid of the urine. All right. Now, these are just some diagrams that might be able to help you as you're drawing your diagrams and annotating, etc. Okay? This is a good one to summarize it for you. Blood enters the Bowman capsule. Okay? Reabsorption of the useful substances happens in the proximal tubule. Okay? And the Loop of Henle adjusts the water level. The urine, which is now all of the urea, excess water and excess salts, passes out the ureter to the bladder. Okay. However, all of the glucose was not reabsorbed. Any water that was needed or any salts that were needed were not reabsorbed. They passed back into the blood to go to the rest of the body. Okay. Now, the bladder. Okay, the bladder is essentially connected to what we call the urethra, and the urethra is controlled by a sphincter muscle. Okay, and that controls whether you go to the toilet, okay, or you don't. All right. So guys, hopefully by the end of this video, you're able to recall the structure of the kidneys. Hopefully you're able to outline how the kidneys are produce urine. And finally, hopefully you're able to explain filtration and reabsorption in the kidneys. Don't forget to like, share, subscribe, and revise. Mr. Asholi, signing out.